Now we're going to get into some syntax stuff that some people will loathe, but it's the way it works. Functions, and we're talking computer functions here, like cos of x or sine. If we did this application, everything in that code was tailored exactly for the trajectory problem when 45 and 85 was angles that we knew, and we could interpret one as too far and one too close. That's great if that's the only application we're going to have this week or this month. However, we're going to be solving a bunch of other nonlinear equations, and it really sucked to have to custom write the same idea. Like the bisection idea is powerful and can be used in a lot of contexts. We'd like to write it in terms of something that we could use somewhere else as well. So that's going to be our goal. To accomplish that, to write more modular code where we can reuse this little piece here and this little piece here, put them together. That's how you actually can leverage all the tools that are in MATLAB or that you're building as you go through the projects. We need to be able to break these things apart, the application from that idea of bisection. So that's going to be our next step. What information do we need to compute the landing point? So we've got our thing here. We've got our trajectory. What values do I need to be able to calculate that x impact? What numbers would someone have to give me before I can say, oh, I know your x impact. It's 35 meters out. Anyone list any of the ingredients that we would need?
The angle.
The angle, exactly. We need the launch angle. If you don't tell me what angle I'm launching at, I'm in trouble. So I need theta naught. Yes. Velocity. Hey, these are sounding familiar. What else do I need? Height. Why not? Exactly. Is there anything else I need? Gravity, exactly. Now, gravity is one of those weird ones because we need it, but it's also constant. So we'll play with that slightly differently. But these three things here potentially are changing. And this is actually a design decision because, say, you were doing this here and then doing it for projects on the moon, gravity might also be an input. Right now, we'll treat gravity as a constant. Is there anything else we need? I don't think so. If you look at our formulas, those are the ingredients, those four numbers. So here's how we're going to do it. We're going to create a new file. We're going to say, as a keyword at the beginning, function, x impact. Now I'll just call it x. Landing x. And it's going to have as inputs v naught, y naught, and theta naught. The key thing, a very key thing, is to put that word function at the front. I'm going to cancel this. Notice it's highlighted in blue, so MATLAB knows what that is. And as soon as you press save on this, it's going to go, oh, do you mean to save this as landing_x.m? And you'll say, yes, that's exactly what I wanted. The name of your function has to match the name of the file, because the file names is actually how MATLAB tracks things down. So we do need landing x to be named landing_x.m and be in the same directory as the directory we're working in, which currently now is notes annotated week 4. All right. So here, we can actually recycle code. So this design process we went through is actually very typical of what I would do in practice. I write a big, long block of code, then realize, this is getting messy. Let's piece out parts of it to somewhere else that I can understand little modules better, and then bring the names of the modules back into the main code. So in our file here, honest to God, the main thing is this part here. That's it. Those 3 lines are what define the calculation of the landing coordinate. And we just called it x. And as was pointed out, we also need to know what g is. So g is 9.8. We have the negative sign taken care of. MATLAB syntax issue. The thing that is called x. So this first line says I'm expecting 3 inputs. They will be called in order, v naught, y naught, and theta naught. So you can screw up the input by giving the 3 values in a different order. This function is going to expect them. It's going to call your first input, whatever it is. It's going to call it v naught from here on in. The thing you put in second is going to be called y naught for the purposes of these calculations. So you have to know that. The second thing is what gets handed back. This function will hand back exactly one number. It will be the number x. Whatever is called x by the time you hit the end of the function, that's what gets handed back. The biggest conceptual barrier for most people is what the heck a function is. All right. My imagination for this is It's a robot or it's a kiosk, and I just built one. It's over there. It's the thing over there called landing X. It does nothing until I tell it to. It's just going to sit there on my hard disk, in this case here, or over there in the corner in my imagination, until I actually call it. Just like, if you want a similar example, cosine. If I say cosine of pi, what I'm doing is trusting that I've got pi. I've got pi here. I'd like to do something with it. I'd like to take the cosine of it. Oh, thank God, there's a function over there called cosine. Here, can you take my pi value? And it does some work and says, oh, yeah, sure, I can take your pi value, and here's your -1 back. It's an information trading system. A function takes inputs that you give it and gives you something back in return. What we've just built is something that does the same thing. We can say landing X. But if you say that, it knows what you're talking about. It says, I know what landing X is. But it's a guy over there going, you didn't give me anything. You're not trading me anything. I can't give you anything back unless you give me my inputs. You tell me what the inputs are, I can give you an output. As soon as we say, oh, right, you wanted a velocity. What was the velocity I wanted? Well, the velocity was, let's borrow them from up here, 20. And we need initial height. Am I getting this in the right order? This is where the order matters. V naught, Y naught, theta naught, yeah. So we wanted that. We wanted a height that was 3, and we wanted theta that was around 62 degrees, because that should land us around 35 meters out. So we have to know what landing X is expecting. He's sitting in the corner, puffing a pipe there. That's great, relaxed. And they say, OK, can you do some work for me? Go ahead and work with these 3 numbers. And it comes back and says, oh, yeah, with those 3 numbers, interpreted as velocity, height, and angle, you're going to land at 35 meters. Perfect. So now I can call on that function anytime I want. I can say, here are 3 new numbers. Can you work with them? Sure. Here's your answer. Here's the landing X that comes from those 3 inputs. And that's incredibly handy, as we'll see. It means we can distill our code back in the main function here. We can actually take all of this out and just say X impact in the main program is what I called it. It's where the landing X is for V naught, Y naught, and it was C before. This last time. So here are the values that I called it in this function. My function and the main program don't have to use the same names. They don't have to, as long as it's the order that matters. What do I put in first? That's going to be interpreted as a velocity. What I put in second is going to be interpreted as Y, because that's the order I put them here. Names don't really matter, but order does. And already we've distilled down 3 lines in our code. And it's actually a little easier to read now. All that other stuff is like, why am I doing roots? Oh, right, because to find the impact point. Now it's saying, all right, I've got my stuff set up. Where do I land if I'm launching at these values? Good. Got it. I can move on. I don't have to think as hard about what each line is doing, because I've modularized that whole calculation off to the side. Let's take a look then at what else we can do. All right. Little blurb about MATLAB functions there, blah, blah, blah. Right, the big thing being current directory, and that's the most typical thing. The other thing people, and I do, quite honestly, is I'll write a nice function like this, and because I've been conditioned to press F5 whenever I finish writing anything, I'm going to run this, and it's going to complain, and I'm going to say this more than once in class and more than once when we have help sessions with you cannot run a function. You cannot run a function. Why not? Because a function is waiting for you to tell it, oh, you want me to do what with what? You've got to give me some inputs. If you just run a function, there are no inputs defined. It goes, I don't know what you're talking about. There are not enough inputs for me to do my job. The error message actually makes sense, which is a nice thing in MATLAB. I can't do my job, so why are you trying to run me? You have to run me with some inputs like that. Then it knows what it's going to do. So you can't run a function. You will run a function. Just recognize that not enough input arguments is usually coming from pressing F5 on a function.